didn't we find this probability on Friday? The one that I asked you to find in number 2? Yes, evil eyebrow, or yes, taco tongue, or yes, evil eyebrow. What does it come out to be? 20 out of 23. And we get there by adding everybody that said yes to taco tongue, which was 16 out of 23. So I'm looking at this piece right here. My or means I'm going to add yes to the evil eyebrow. How many people said yes to evil eyebrow? 14. But then we have to subtract out our intersection. We have to subtract out the people that said yes to both because we counted them in both of those numbers. How many people said yes to both? 10. So 10 out of 23. We subtract the people that we double counted. This is called our intersection. This would be yes to taco tongue and yes to evil eyebrow. So far, so good? All right. So 20 out of 23 for both. Let me actually pull that one over here. I want to look at what number 3 is asking us. Given that the person selected is a yes evil eyebrow, what's the probability that they are a yes taco tongue? Write it as a fraction, a decimal, and a percent. I want to break down this first piece here. Give it a different context for a moment. If I were to walk in the day after a test and say, given that nobody in here failed that test, what do you immediately know? Everybody got at least a 60 or higher. So if I say, given that, I'm giving you information that now you know is a fact. Given that the person selected is an evil eyebrow, or yes to evil eyebrow, we know this about that individual. It's no longer a probability, it is a given. So there's no longer, like in my first example, there's no longer a chance that you failed. We know everybody passed. And then we're going to talk about what happens after that. So if I'm using this table to help me narrow this down, if I say, given that the person selected is yes to evil eyebrow, where would I look on this table for information after that? Every piece of information would have to come out of this yes evil eyebrow here. So given that the person selected is a yes evil eyebrow, what's the probability that they are yes taco tongue? 10 out of 14. So here's the way I write this probability statement. Probability of yes taco tongue, and then I do a line here, and after the line is my given information. Yes evil eyebrow. This is my given. And you said that was going to be 10 out of 14. So I wrote it as a fraction. They also asked me to write it as a as a decimal. So grab your calculators. Let's divide it on the calculators. We're going to take this out to at least 3 decimal places. With probabilities, we want at least 3. Sometimes we want that 4th one. What would this be out to 3 decimal places. 0.714. And so as a percent, 71.4%. The reason we want to take our decimal out at least 3 places is if all I said was 71%, this is really closer to 71.5%. And that gives me some additional information. 71 and almost a half is different than 71%. I want you guys to try number 4 on your own. Before we go through number 4 together, I did want to remind you guys of the general addition rule, which is what we used up here. This is one of the things that is given on that formula sheet. However, they use the notation for or instead of writing the word out. Does anybody remember what probability notation for an or looks like? It looks like the letter U. Looks like this. The other way we talk about it is a union. If I want to know this or both, I'm bringing everybody together. That's a union. And back here with the and, does anybody remember what that probability notation looks like? That's the upside down U. It almost reminds me of a capital letter A when I see it like this, because I'm like, oh, if I just do that, it's a capital A. So that's how I remember the and is an upside down U. And is just that little football part. The or, the union, remember we want the Starbucks or, coffee or cream or both in there. You will be given this. You have to know how to use it though. All right? For number 4, given that the person selected is a no evil eyebrow, what is the probability that they are a yes taco tongue? I want to write this notation out first. What is the thing that we want to know the probability of? Not what they gave us, but the thing I want to know the probability of. Yes, taco tongue. Given that, the condition, the thing that they've told me now that I know is no longer a probability, it's a certainty because I know this. What are they giving me? They're giving me no to evil eyebrow. So again, this part right here is my given part, or my condition. I'm going to pull that table back up so that we can look at it together. What's the probability that they are a yes taco tongue if we know they are a no to evil eyebrow? 6 out of 9. What is that as a decimal? 0.667. We round that last one, yes. So as a percentage? 66.7%. Beautiful. These guys right here in number 3 and number 4, these are called conditional probabilities. Conditional probabilities. In conditional probabilities, I already know that some condition has been met, and so that kind of narrows down what I'm looking for. I would not take my conditional probabilities out of the entire class, because I would only have the people that were yes, evil eyebrow, stand up, and we would only be counting from that group of people for number 3. Or from number 4, only the people that said no to evil eyebrow, you stand up. And now I'm going to find the percentage of those people that are also yes, taco tongue. Does that make sense? So whenever they give you a given that, sometimes the language will be a little bit different, but the idea is they're giving you some piece of information. Like when I was providing the example at the beginning of, given that everybody passed, I might just walk in the room and say, like, everybody calm down, everybody passed. I'm giving you that condition, even though I didn't start with the words given that. Does that make sense? Look down at number 5. We're going to start with a definition here. 2 events are independent if knowing whether or not one event has occurred does not change the probability that the other event will occur. Or in my own words, if I know one event happened, if they're independent, that doesn't help me make a better guess about the other event happening. If they're independent, knowing one thing doesn't help me at all with the other, because the probabilities are exactly the same. So looking at the answers that you wrote down to number 3 and number 4, does it appear that these 2 events are independent? If you know somebody can evil eyebrow, and then I ask you to guess about whether or not they can taco tongue. If you know they can evil eyebrow, is there a better or worse chance that they can taco tongue? What'd you say? There's a better chance. If I know for sure they can evil eyebrow, 71% chance they can taco tongue. If they can't evil eyebrow, is it this high? No. So I can make a better guess with this information. I would say that no, these are not independent. People who can evil eyebrow are more likely to be able to taco tongue also. Does that mean that people that can't evil eyebrow can't taco tongue? Just means there's not as great of a chance. It's still more than half of the people that could do the taco tongue, right? Still almost 67%. But if I know you can evil eyebrow, I'm like, I bet you can also taco tongue. Go ahead and turn the page for me. Let's look at the back side of this. Take about 2 or 3 minutes, either on your own or with a partner. Try to answer these 4 questions here. Remember, if it comes after this little line, this is our given information or our conditional information. This is what we would know. Take a moment to come up with these 4 probabilities here. Okay, so we've got data for the seniors at Eastern Kenwood High School. What proportion of these seniors can taco tongue? 480 out of 600. What is the proportion of seniors that can taco tongue, given that we know they can evil eyebrow? 180 out of 200, or 90%. What proportion of seniors can taco tongue, given that they cannot evil eyebrow? I'm sorry, how much?
180 or 480.
Yes, taco tongue, no evil eyebrow. So 180 out of 480 would be yes, evil eyebrow out of yes, taco tongue. I see what you're looking at there. This one right here, this no evil eyebrow, I want to find that and follow that all the way down. 300 over 400, yes. Or 75%. Are yes taco tongue and yes evil eyebrow independent? Are they independent? Independent means knowing whether or not they can evil eyebrow gives me no good information to make a better guess about whether or not they can taco tongue. They are not independent. Which group is more likely to be able to taco tongue? The yes evil eyebrows or the no evil eyebrows? If you can evil eyebrow, you've got a better chance of being able to do this. You've got a 90% chance of being able to do this. They are not independent. Leave that up for just another second. I want to look down at number 7. We're going to fill this table in as if they are independent. We're going to fill this table in as if they are independent. What proportion of students did you say could definitely taco tongue?
480 out of 600.
480 out of 600, which was what as a percentage?
80%.
80%. So 80% of the kids can taco tongue, which means 20% of the kids can't. So if these are independent, what proportion should be able to evil eyebrow? What proportion of the yes evil eyebrow kids should also be able to taco tongue? How many did we say could yes? 80%. So of this column right here, what proportion should go right there? What percentage of this should go right here? 80%. What is 80% of 200? Use a calculator if you need to. What is 80%? 160. Which means 20% would not be able to. If these were independent, 80% can, 20% can't. Fill in this column for me here. So of the seniors that say they cannot evil eyebrow, of those 400 seniors that say they cannot evil eyebrow, if these events were independent, how many of those students would we expect to say, yes, they can taco tongue? Same proportions as before, 80% can, 20% can't. So what will go here? 320, 80% out of these 400. So what would we expect to have here? 80, yes. Again, this is if they were independent. Using this new table, I want you guys to find the same probabilities we did up above, but using this table of information now. This is the assuming they're independent table. Find the same three probabilities that we did up above for A, B, and C. What's the probability that somebody is a yes to taco tongue? What is the probability that somebody is a yes to taco tongue given that they're a yes to evil eyebrow? What's the probability that somebody is a yes to taco tongue given that they are a no to evil eyebrow? What is our probability, our proportion for yes taco tongues? 80%, yes. For 80 out of 600. Probability for yes to taco tongue given that they are a yes to evil eyebrow. Where am I looking on the table? Because once I have a given that, I'm not looking at the whole thing anymore. So I want to look at 160 out of 200. This is my given, so that narrows down where I'm looking on the table. Yes, evil eyebrow, I find that. That's going to be a column here for me. So 160 out of 200, which is what as a percent? 80%. What about yes to taco tongue given that we know they are a no to evil eyebrow? 320 out of 400. What percent is that? 80%. What do you notice about these percentages? They're all exactly the same. Did knowing anything about evil eyebrow give us any extra information about whether or not they could taco tongue? That's what independent events look like. When my probabilities are equal, the probability of just yes to taco tongue, the probability of yes to taco tongue, no matter what other information I have, it all stays the same. Those are independent events. I have the probability notations for these written off to the side. We're calling taco tongue event A. The probability of event A is what we've answered right here. The probability of event A, given that we know event B has happened. What does this little C thing mean? Complement or not. Here, this is yes, evil eyebrow, so this is not evil eyebrow. Does that make sense? What do you notice about the answers to number 6 versus the answers to number 8. Exactly correct. The answers to number 6 are all different. The answers to number 8 are all the same. And those were the ones that were not independent. Answers to number 8 are all the same. Getting additional information did not change our probabilities. So we're going to complete this generalized statement. If we let A be yes taco tongue and B mean yes evil eyebrow, then if the probability of A is equal to the probability of A given B is equal to the probability of A given B complement, then the events are independent. The probability of event A did not change when event B did or did not happen. What goes on with event B doesn't matter. Then they're independent. Get our big ideas written down. So if you flip over, I believe it's page 13. Big ideas for today. Conditional probability. The probability of A given B, or I know that event B happened, is equal to the probability of A and B, they both happened, divided by the probability of just B. This is what you guys were intuitively doing when you were setting up those other probabilities. My independent events, when knowing one event has or has not occurred, it does not change the probability of the other event. So if the probability of A is equal to the probability of A given B is equal to the probability of A given B complement, if those are all the same, then the events are independent. I have an alternate equation underneath there. You don't have to remember that one. It's just another way to find the same thing. All I did there was take some substitution. This right here is what we have an equation for over here. So I took this and I substituted it in the place of this one. And then I can multiply both sides by the probability of B. It's just some algebraic manipulation. If you remember this piece right here, this is the big, most important part. Down here is just algebraic manipulation with this. Once you get that copied down, take about 5 minutes to answer the 3 questions down at the bottom. We will go over those at 9:40 which is about 6 minutes from now. So that should give you time to write down and answer those questions. And then we'll go over those at 9:40 so that we have enough time to go through all three pieces. So what is the probability of C given S? First of all, what does C mean? 4 or more children. What does S mean? They talked to them in 1976. So the probability of C given S, where's the only place on this table I'm looking? Every number I need is coming out of this column right here for 1976. So what is the probability of 4 or more children if we know this mother was surveyed in 1976? 40%, 40 out of 100. So we're looking at 4 plus children and 1976. That's this piece over just 1976. So far, so good? Cool. In context, given that the mother was surveyed in 1976, or I know she was surveyed in 1976, there's a 40% probability that she had 4 or more children. All right. I've got all that, but just kind of written out long here. Given that the chosen mother was not surveyed in 1976, what's the probability that she has 4 or more children? Go back and look at the table. Given that she was not surveyed in 1976 means that I would want to look where on the table? 1994 and 2014. So I'd want to look at these two. So it'd be out of how much? 200. Out of 200. How many mothers in 1994 had 4 or more kids? 13. And in 2014, 13. So altogether, 26 moms that were spoken to in these 2 years had 4 or more kids out of the 200. So 13 in 1994, 13 in 2014, out of 100 that were spoken to in 1994 and 100 that were spoken to in 2014. For 26 over 200, or 13%. Are these events surveyed in 1976 and 4 or more children independent? No. Mothers surveyed in 1976 are more likely to have 4 or more children than mothers not surveyed in 1976. Or another way of stating that is that the probability of C given S is not the same as the probability of C given S complement. If they were independent, these two probabilities would be the same. Right at the beginning of class, I passed out your 5.3 homework, which means 5.2 is due tonight. 5.3 is going to be due on Wednesday. Tomorrow I'm going to go ahead and pass out the review for the test that you guys, so that you guys have that in your hands. We still have one more day of material to cover. And then we've got Wednesday and Thursday to prepare for your test. I'm still sitting on the fence about whether or not we bump this to Monday. The question is just whether or not we want to test after the weekend or before. So We'll kind of talk about it after we're done covering material and after we've had one day to look at the review.